Welcome to the course Stability Aspects of Structural Steel Design, Concepts and Applications. Over the past several weeks, we have been talking a lot of theory on connecting the codal provisions along with the stability aspects. But let's talk a little bit about the application of plate girders in this session. So what we are going to see today is basically an application of plate girders, especially a curved plate girder, an overview of fabrication and construction. I am very much interested in plate girders because most of my training both in masters as well as in PhD was based on horizontally curved plate girders. And what you are going to see today is basically a part of my PhD work that I carried out on constructability aspects of horizontally curved plate girders. So this is the Galleria Flyover Bridge project, and what you see is basically the map of the United States, and on the rightmost side that you can see in the south there is a state called Alabama, and Galleria is a place very close to the city of Hoover and Birmingham, and we are basically going to talk about a flyover bridge that connects the Galleria Mall with the Hoover city. You can see the highway I-459. A closer look at the I-459 shows you that there is a bridge that is connecting the Galleria Mall from I-459. What you see on the right hand side is basically a huge mall. I've been to that mall. It's a very nice mall to spend time there. The project is called I-459 Galleria Flyover, Hoover, Alabama. Hoover is basically the city's name. It is a suburb of the greater city of Birmingham. And the objective is to improve traffic flow and accessibility to the Galleria Mall. And you can see a picture of I-459 south ramp to the Galleria during construction. Let's go step by step. The first one is the design and planning. The flyover structure is an elevated bridge with horizontally curved eye girders. When I say horizontally curved girders, don't get confused with its cousin, the arches. The arches are vertically curved. Here we are talking about a bridge. When you look at the plan from the top, it is horizontally curved, and hence it's called horizontally curved eye girders. The ramp configurations are, it's a two-lane exit from I-459 south to the Galleria Mall and two-lane entrance from the Galleria to I-459 north. The challenges considered are heavy traffic management during construction, and large girder spans require specialized fabrication and lifting techniques, especially for horizontally curved girders. The construction execution, basically a sequential construction approach was followed, first by ramp erection and followed by decking installation. The next important thing is the traffic rerouting to maintain vehicle flow. So the challenges in fabrication and construction, there are several fabrication techniques that are available for horizontally curved girders, especially for the flanges. So the special methods are cut curving, heat curving, and cold bending introduce stresses. And transportation, the girders require careful restraint to prevent instability. As you can see that the girders are transported in large trucks in the picture shown below. The erection requires specialized lifting techniques and temporary basing. And you can see the next picture that shows how the girders are being lifted through cranes. Deck hardening, something that you pour concrete, and additional support is required to prevent distortion because, as you know, concrete is a liability during the deck pour and becomes an asset only after 30 days or it has been completely cured. So we need to prevent any distortion that could take place to the heavy dead weight of the concrete, wet concrete during construction. So this requires additional support. The first and fundamental question that we also should understand is that why are curved bridges more complex? Curvature basically magnifies forces and deformation, so it introduces torsion in addition to bending. The picture shows the horizontally curved nature of the bridges. Also, the residual stresses from fabrication can weaken girders. The stability issues arise in transportation and erection, more so for curved girders than for straight girders. And the first fabrication method is the cut curving method. Here the flanges are flame cut from steel plates to the required curvature, but the pros are it achieves any radius of curvature. The cons are that it is labor intensive and material waste due to scrap is very high when you do cut curving process. Basically the ones that are away from the curvature are ignored. The next one is the heat curving method. In heat curving method, you basically fabricate an eye section which is a straight eye girder, and then you heat and cool the steel flanges at several locations using controlled bending. And the methods are continuous heating, strip heating, or B-type heating. Here the pros are it is most economical and there is little material waste. And cons are required precise temperature control and specialized equipments. Basically, it is an art in heat curving, and the most common type of producing a horizontally curved girder is by V-type heating. Several state Department of Transportation in the US have expertise in V-type heating. Basically, they put the eye sections in a flat portion where the flanges are basically vertical and the webs are horizontal, and it is supported at several locations, because if it is going to be a large girder, it is supported at several locations. In between the supports, you apply a V-type heating, basically heat at several strategic locations to achieve the desired curvature. Once you have achieved the desired curvature, you stop heating. The third one is the cold bending. In this, the process is a straight girder is plastically bent beyond the required curvature and then released to relax into the correct shape. Basically, it is called a rebound effect or elastic relaxation. The pros are it is fast, efficient and precise. The cons are there is a potential risk of fractures and not yet widely accepted, because when you are bending the girder without providing any heat, when it is doing cold bending, especially when it is cold bending, there is a possibility that it could crack, and once it cracks, then it's not something that is desirable. So let's look at the glimpse of fabrication of a curved plate girder. The first one is the material preparation. In this case study, the fabricator is located in Montgomery, Alabama. Montgomery is the capital of Alabama, and the name of the organization is Carolina Steel Corporation, who fabricated the plate girders. And you can see that the steel plates purchased were from 2.74 meters, 108 inches wide, and the web plates were cut with programmed machine for camber and sweep. By camber, I mean it is bent in the major axis, and sweep is something that is bent in the minor axis. The designer specifies whether heat or cut curving is required for the sweep. So the web lies flat and the flanges are positioned vertically for tack welding. A specialist machine aligns and applies pressure to hold flanges in splice. Flanges are first tack welded and then the girder flipped for full welding. Here, full welding means it's a submerged arc welding, which is typically used in India as well here in these days in a pre-engineered building factory. Before we go into that, we also need to understand the welding process. In the welding process, preheat is applied, as you can see from the picture here. This is required because in places like US, where there is going to be extreme changes in climatic conditions, suddenly heating the girder will lead to cracking. So we need to ensure that there is a preheating that takes place before heating is applied. So when you do preheating, then there is the delta, the difference in temperatures is very, very minimal. So we have to do preheating of flange plates welded to web. So now the process is continuous fillet weld joins the flanges to the web, and flipping the girder ensures complete weld penetration. The weld sequence is carried out to control minimize distortion. So you don't weld continuously. You can do what is known as strip welding, where you can weld certain portions and then you leave some gap and then you weld certain portions. By this way, you reduce the amount of heat that is input, and which will internally minimize the distortions. What you see on the rightmost side is basically the submerged arc welding. And next, the stage 4 is the camber induction. Camber is checked and additional camber is induced if needed. The girder is held with web vertical and flanges horizontal. The heating and self-weight creates the necessary camber. As you can see that there is a noticeable camber in the painted girder, as you can see on the right hand side. The next one is the sweep introduction. The sweep is basically bending in the minor axis. The sweep is introduced after camber verification. V-heating method is used if cut curving is insufficient. So if the fabrication method is cut curving, then still you use V-heating method to introduce sweep. So note, in V-heating method, the heat is applied in V-shaped pattern along the flange of the girder. The apex of the V points towards the desired direction of the movement. So this is something that we have described previously also. Basically, you provide heat in the flanges and the apex of the V points towards the desired direction of the movement. So basically, if you want it to sag, you apply the heat at the location where it is closer to the ground. So you heat it and then it deforms plastically. Once it deforms plastically beyond the yield, it starts to give away, and due to self weight and the loss in material capacity, it tends to sag, and that sag can be treated as a curvature. The self weight and controlled torching heat creates the required sweep, just as I mentioned. And the next step is the stiffener and diaphragm installation. So stiffeners, diaphragms and attachments are installed. So you can see the picture where the girder is ready for stiffener installation. You can also see at one corner there is a small triangle that is located there. This is what we described in the previous class by about 15 mm. This can also be called a scope, but this is basically done to ensure that there is not much of a difficulty at the location where the web and the flanges are connected using welding. So this gives some real estate space for it to get itself accommodated. Then the stiffener is tack welded to the girder, as you can see on the picture, followed by the stiffener getting continuously fillet welded to the girder web by machine welding. If there are any additional pieces, they are hand welded to the girder. You can see the welder actually here is doing some kind of a manual welding. After that, the top flange is marked for sheared stud placement because it is going to be a composite girder. We need to make sure that how many studs are being placed, and the exact location of the studs. This is done using a chalk piece, as you can see on the right hand side. Once that is being done, you can see the finished girder with the stiffeners and studs, etc. The studs are required basically for composite action. So it will prevent the slip between the concrete and the steel plate, ensuring more composite action. More the composite action, more is your ability to carry load. Then after that, there is a separate fabrication base used for diaphragms and other components. This is a picture that shows the building of the diaphragms. Diaphragms also mean basically cross frames. The next is surface preparation and painting. The plate girders are blast cleaned before painting, because if you don't clean it properly before painting, then the paint will not stick with it and it will come out very quickly. So the cleaning can be done using a blast cleaning machine or manual blasting hose. Typically it is used by steel balls. The steel balls are kept in inside a machine, and it is hit at the plate girders, and then all the dirt that is belonging to that will come outside and it is clean. And once it is clean, it is immediately painted before rusting could happen, and again that will create trouble. So as soon as the blasting is done, you should start painting it. So the girder is painted in sections using crane lifting, as you can see here. You can see that the girders are slowly lifted and it is painted in sections using crane lifting. Next is the size and weight specifications. This is one of the largest curved girders at that time. It is 8 feet in deep, and you can see the size perspective of the girder. You can see a tall man that is standing close to the girder. So he is very short compared to the girder, which means that the girder is much taller. And the web thickness is typically 18 mm. The flange width varies from 16 inches to 42 inches, or basically 410 mm to 1070 mm, depending upon the analysis part where you need more bending moment and shear force. The flange thickness is basically 1 inches to 3.75 inches. 1 inches is 25 mm to 95 mm. So the flange thickness can be a huge, right? What you see on the right hand side shows you the flange thickness perspective of the girder. This is in the thickness direction. You can see a person who is actually keeping his hands to help us understand what would be the thickness of the flanges. The heaviest girder is basically 2 metric tons. The longest girder between the splices in this project is 106 feet. And the maximum weight of the girder is 68.3 metric tons. Next comes the transportation and storing. First is the transportation logistics. You can see that the trucks are lined up and parked near the construction site on the picture on the right hand side. The girders are transported by Hirschfeld steel trucks from Montgomery to the Galleria. And coordination between the erector and the fabricator ensured a timely delivery, because there needs to be a good coordination between the erector as well as the fabricator. And the driving list is created based on erection sequence. So you need to know which girders are going to be erected first and which girders are going to be erected second and third, and so on and so forth. So it becomes very essential for you to sequence the position of the girders, and then accordingly the transportation should be carried out. So the girders that are required immediately will be transported to the construction site. And the trucking methods are two types. One is for a short girder, which is transported on a flat trailer. So basically when it is very short, it is a flat trailer that is used. The next one is called dolly. The long girders are transported using a dolly for better maneuverability. Basically, if the girder is very long, then you should have some kind of a easiness with the truck, as well as the front portion of the truck, as well as the back portion where the girders are being transported. So a dolly is some kind of a special mechanism where the truck and the backside of the truck need not be in one line. So the truck can move, and accordingly the flat portion behind the truck or the backside portion of the truck will move in a different fashion in order to ensure maneuverability. So the dolly basically has its own steering mechanism for navigating tight turns, because the length of the girder is very high. So if you don't have a dolly, it will be very difficult to be transported, and especially at locations where you have to take a tight turn. So next is the storage at job site. So the truck and the dolly trailer is left on site when storing girders. Next is the waiting trucks lined up on the interstate until the cranes were ready. So we have to line up the girders, because the next operation is basically the cranes that have to pick up the girders and place it on top of the piers. Crane positioning was critical because closer truck access reduced crane reach. The crane should be such that it can easily lift and put the girders in place without having much effort. Now, we also have to take into consideration the weight and the size consideration. The girders ranged from 10.4 meters to 36.3 meters. The picture on the top gives you the length of the truck with the girder, and it also shows the width of the truck. The width of the truck shows how much curvature that you can accommodate in the plate girder for transportation. The height is also shown here. So these height, weight and size considerations are absolutely essential for safe transportation. Here in this case, the weight ranges from 6.35 metric ton to 65.3 metric ton, and the truck weight limits require special permits for oversized loads. So when the width is standard, it is 2.6 meters, no permit is needed. When the truck width exceeds 8.5 feet and it is closer to 12 feet, we need a permit. When it is closer to 16 feet, we need a permit with an escort. Escort basically is one kind of a vehicle that goes up front, alerting people that a bigger vehicle is coming behind it. The next is the height limit. The height limit is 4.11 here, and it varies by state and bridge clearance. This actually shows, the picture on the top actually shows the crane lifting illustration. Here, if it is a shorter distance, as we described in the previous slide, there is not much of a difficulty. So it has a smaller overturning moment. But if it has a longer distance, then there is a larger overturning moment, and you need to be careful considering these things, and therefore the crane location has to be judiciously selected such that the large overturning moment can be reduced. Next one is the erecting. The erection team and planning is absolutely essential. Careful crane placement and the use of spreader beams with 2 pickup points are carried out. You can see the spreader beams, that is basically the brown color steel girder that you can see, that is a spreader beam. And then you have girder docks, which basically the girder docks are the basically the clamps that you can see. And next one is the lifting and placing of the girders. Crane lifts the girder and placing it onto supports or splice connections. Now the ironworkers align the girders and place the bolts using spot wrenches. The third one is the pickup point considerations. Pickup point is where to pick the girders, right? So ALDOT is basically Alabama Department of Transportation, requires lifting points between third and quarter points along the girder arc. So this is because it is a curved girder. If it is a straight girder, it is very clear that you have to take the pickup points from 1/4 point. Because the curved girder introduces twisting effect, the pickup point should be between 1/3 and 1/4 of the length of the girder. So for long girders, that is 36.3 meters, had long spacing between the pickup points. So the girder docks and tag lines were used to prevent twisting and rolling. So the girder docks basically are the clamps that are used for picking up the girders, and the tag lines along with the girder docks are used to prevent twisting and rolling. The next one is the splicing and stability measures. Multiple girders are spliced together for long spans. First girder held by crane until next girder is aligned and bolted. So you do step by step. If you miss anything, then there is a disaster waiting to happen, because sequencing the girders is very, very important, because the girders are designed for composite action, but before the concrete is poured, you have to make sure that the girders are held by crane until the next girder is aligned and bolted. Up to 6 cranes used at spans requiring 3 girder splices. So for 3 girder splices, 6 cranes are required. Diaphragms are bolted between girders for stability purposes. Here the diaphragms mean cross frames. Basically they connect the 2 girders. If you are picking up a single girder, there is a tendency for it to have instability. If you have 2 girders that are connected through cross frames, then the instability reduces and the structure becomes more stable in configuration. You can see the pictures here how the girders are being lifted and put in place here. Here you can also see that the big clamps, the red color clamps, are also known as the girder docks. And here you can see, although not very highly visible, the tagline showed at the left end of the lifted girder. And there is a slight tilt to the girder during lifting, which is obvious and expected, because if you don't have the proper clamps at that location, there could be a twisting effect that would take place. Basically, what they do at the construction site is that they put the clamps with an assumption between 1/3 and 1/4 points. They lift it slightly and see whether it is stable or not, and then they start iterating at the site, and then they put the girder docks and then they lift it. But sometimes if they don't iterate it properly, there is a tendency for it to tilt, and one such tilting is actually shown in the picture on the rightmost side. So this actually is the constructed I-459 south ramp to the Galleria. You can see a closer look at the girder field splice at the Galleria flyover. So this is basically the splicing that takes place between the web to web. As you can see here, a number of bolts are there. That is, you can also see that at this location there is a change in the cross section. Basically, the flanges are getting reduced. The width of the flanges is slowly getting reduced. As you can see that there is a transition, there is a tapering that takes place at the splice location. And this is also the place where the splices are put, because there is a reduction in the bending moment at that location. And hence the cross section is reduced on the right hand side of the picture. This will result in lots of cost savings because there is a reduction in the moment capacity at those locations. What you can see here is also the flange splice. You look at a closer look at this one, you can see the flange splice at the bottom of the flange plate. This is also connected by putting a plate at the top as well as at the bottom, and you can see that it is connected by a number of bolts at this location. Now let's look at the splice connection and design recommendations. One, the location optimization is important. An important thing is to avoid splices in high stress regions as well as supports or points of maximum bending moment. Prefer locations where the bending moment and shear forces are relatively low. And the next one we need to understand is the bolted versus welded splices. The bolted splices are preferred for ease of erection, maintenance and fatigue resistance, because there is a small gap in the bolted connection because the bolt hole is bigger than the bolt, and then it will help in increasing the fatigue resistance. Welded splices should be avoided in the field due to quality control challenges, because the quality of the weld at the site is typically questionable, whereas the bolted splices are very good and it is the most preferred during construction. So this is the I-459 south ramp from abutment to bend, and you can see that the girders fitting up to make the field splice, and the girders are supported by each crane until diaphragm and splice bolts are tightened, as you can see on the picture on the rightmost side. The first line of girders from bend to bend is shown here, and then the second line of girders are about to begin. Now you can see this is the last picture here. The deck is installed after all the girders have been installed and the bolts have been tightened. With this one, we come to the end of this small sharing of my thoughts on how girders, basically bridge girders, are designed and erected in practice. And these are some things that as a student it is very, very important for you to understand, that what you do in a design class calculation in a classroom setting is very, very minimal, and what you do at the site is something that is very interesting to know how the design is translated into an actual product at the site being constructed. So this understanding is very important. This understanding will help you to design a better structure, a safer structure and a more economical structure. Thank you so much.